Hello, welcome to Modern Application Development. In this week, we are going to go beyond our basic understanding of HTTP that we looked at last time. We are going to study our applications by using the browser web dev tools and also going to examine what they look like in detail on the server side. Just as browser development tools allow us to understand how the browser views the requests and what it is doing with the current request, on the side of the server, we need tools to understand how it is that the server experiences our requests. Our primary tool for this is logs, and our server setup will have many features that go towards both understanding the server-side behavior as well as being able to deploy several services on the server at one time. As we did last time, we will continue to use the XAMPP bundle and use Apache and Tomcat and all the tools that it provides. As I noted last time, if you want to, you can install XAMPP on a USB stick so that you can carry the project around as needed, which is very convenient. The other tools that we will use this time are curl, shell scripting, and Java. For the shell, we will also use a few Unix utilities like awk, etc. to be able to write small scripts that show us what is happening on the server side when our requests get made. We will use our Java command line program wrapped as a CGI script as we saw last time. Deliberately, our use of Java in this example is pretty minimal. It is straight procedural programming with no object-oriented or any other kind of structuring. Okay, now let's go ahead. In this session, we are going to go deeper into the details of how it is that server programming is different from ordinary web programming. In particular, the details of how browsers and servers interact. Last time we began with basic examples of interaction in the HTTP GET method, and this time we are going to study our applications which use both the GET method and the POST method. And we will see both of those with the browser web dev tools and take a look at what those tools have to tell us about our use of the facilities of the HTTP protocol, of the browser, and of the server. Since browsers depend on HTML and they render that HTML into a view for the users, we will also study some of the aspects of how HTML can be seen on the browser side in the form of a model called the document object model, which is a set of objects inside the browser that are used to put together a tree of document elements, which is what we actually experience as users. One interesting thing about the split of the program into two pieces, the browser and the server, is that the connection between them tends to be rather thin. The browser has to convert our interaction into just enough data for the server to be able to compute with and return the results that we care about. The primary difference on the server side is that unlike a desktop program which gets started and stopped, there's no such thing as stopping a server-side program. If one user is not using it, another one is. This means the program is perpetually in use, and so making changes to the programs has to be done in such a way that people do not experience any kind of disruption, or at least that the disruption they experience is absolutely minimal. Therefore, deploying servers, that is deploying programs to servers in such a way that people can use them, is an art in its own right, and we will see the beginnings of this as we look at how pieces of a program are assembled and deployed to servers. We will also begin to understand how the existence of URLs is both a help and a hindrance to the creation of server-side programs. Let us examine all the elements of the system that we are going to study this time. First, we have the browser. as for last time, but unlike last time where the browser was simply something that sent HTML requests, HTTP requests, and expected HTML responses, this time we are going to spend some time on the DOM, which is the internal structure that the browser has. Next, when the browser sends a HTTP request to the server, we are going to see how it deals with the contents of a form. We have seen one example of form contents when we looked at search boxes last time, but this time we are going to look at it when we are submitting some data which is supposed to change what is there on the server. Then for the HTTP response, we will have HTML and CSS, and we will take some time out to see what that structure looks like. On the server side, we are going to look at the deployment of programs, and more specifically, we are going to look at the nature of log files, both for the servers by themselves and log files which are specialized for our application. Let us begin with a review of the things we have discussed last time. What we have here is the basic structure of a web app and the text protocols and encodings. From last time we have that there is the user whose events go to an event loop which is running within the browser. The browser presents the UI to the user. It is written in HTML, and such things as filling in text and buttons are the primary means of user interaction. Then the browser converts the user requests into HTTP protocol requests and will eventually get a response back from the server. Meanwhile, the server gets the data from the browser, gives it to the CGI or the command line program in the form of environment variables and standard input, and returns output as standard out. And finally, it may or may not use a database or a file store. Usually, of course, because we want to have long duration data, the programs on the server side will inevitably be storing something, so that the next time when the user comes back, their data can be retrieved and given to the user. All this we are very familiar with, and this is the cycle that we have to keep in mind as we start analyzing the pieces of this cycle. Okay, next thing we understood last time was that form contents are mapped into query strings, but that is what happens for what is called the get method. And what this exactly means is what we are going to discuss this time. As we saw last time, we have a query string, and also you can think of this as a kind of different syntax for a function call. But the new idea this time is that there are methods other than just the get method that we normally saw last time. Okay. Finally, last time we had this other idea, which is the notion that there are such things as headers which help organize the protocol data. These headers, 1 and 2 in particular, relate to the service that is being provided, while the rest of the headers about user agent and what kinds of data the user agent accepts, etc., relates to the capability of the client. The new idea here is to call out this particular part as what is called an HTTP method. Okay, the next thing we studied last time was HTTP response headers, which contain the response followed by whatever data the server wants to send. Here, the new thing that we will dwell on this time is the existence of error codes and the interpretations that are put on them. We saw some briefly, but this time we will see some more. And once the headers are done, the data begins. These headers are something you will become very familiar with once you become a web programmer. That's the review for what we have so far. Now let's start looking at the details for this session. Let us begin our study of the HTTP methods and return codes by looking at our command line app. As we saw, in the first line of the HTTP header, a method is mentioned. If the method name is get, then a request is made And the expectation with get is that when we request the resource abcpqr, if we use the method get, then we are not going to change the state of whatever resource is there. However, if the post method is used, then whatever resource we have requested, we can change its state. In fact, a post method is there in order to ask the resource to be changed. Besides get and post, there are other methods like head, trace, put, patch, etc. Head and put are occasionally used, but the rest of the methods should actually be blocked, although they were designed for convenience. Given that the internet turned into a difficult place to keep secure, you do not want to expose any facilities to the outside world that somebody might use because you inadvertently did not know that they existed. This keeping minimal facilities for the outside world is called the reduction of the attack surface, which is an idea that we will look at later when we understand what it takes to secure our systems. Now let's begin by looking at demos for various elements of our application. Let us start by opening our web browser tools. Here we go. And what we are going to do is to begin by shift reloading the application so that we see the natural form in which the application comes to us. And here we can see what the requests look like. First of all, we have the get method. The status is 200, so we know everything is okay. The domain, of course, is localhost, and this is the URL we are looking at. It's a HTML document, and there is a transfer and size and so on. As we looked at last time, favicon is a standard request that is made for the first time a page is visited. So let's look at the details of this thing. Nothing unexpected here. We have the URL, we have these various headers, and you can take a look at, like I said, any application that you happen to use to figure out what it is actually doing. So far so good, nothing unexpected. Now let's see what happens. When we first try to enter this box, there's something interesting. The cursor is actually blinking at a tab. So somehow a tab seems to have gotten inserted. This kind of thing, it doesn't matter much for simple applications, but careful designers take a look at the detail fit and finish, as it were, of the application. So somewhere we need to take some action to remove this extra tab character. But for now, let us just remove the tab. Aha! As we remove the tab, we see that there is actually a sentence here saying enter your command sequence here, which is a sort of a help text that we have entered. And let's see what happens and what the tab is doing and so forth. But for now, having entered the tab, we are ready to give the command line applications. So let's begin. So we have register F1, F2, and we have, let's say, expense F2 200, and let's ask for a report on F1's behalf, and then we have end. As it says, enter your command sequence terminated by end. We submit the form and we get the result. This is telling us that these are the registered roommates, these are the expenses, this is what F1 owes, and the database details are also printed out. On the developer tool side, we have this time the post method, and we have the URL that was called, which is fairshare2.sh rather than fairshare2.html. But there is something a little odd in the sense that although the document's name is sh, the type is HTML. So this is one of those interesting things about the web. In the beginning, we saw that a file that ends with .html is also of type HTML, but nothing in the system actually looks for any connection between the names of the file and the type of the file. The type of the file is given purely by this kind of response header over here. So just as the response header here says text HTML, that is actually the file type. Now it has nothing to do whatsoever with any kind of extension or anything like that. We made a post call and our request was like this. In all this, if you take a look, it says content length is 73, which means those sequence of commands that we typed were 73 bytes. It says content type is application XWW form URL encoded, which means that data was somehow encoded when it was sent to the server. But where is the data? This data is normally not shown over here, and there is a sort of a indirect step that you have to take to look at the data. If you press this edit and resend button here, you will find that now the tools allow you to actually make a post request, and if you need to, you can edit this data. Of course, compared with our original data, let's take a look at the original data by going back. The original data, oh, oops, I guess I made a mistake, because as soon as I said back, the nice little inspector tracked me. Fine. Anyhow, so this is how the commands we typed looked like, but that's not what they seem to be in the inspector. So let us submit all over again, and let's see this time what happens when we go to edit and resend. Okay, now compare this with your memory of, unfortunately, the request that we had made earlier, because if we go back, then the system will change again. So we have register F1 and F2, and after that, so first of all, the spaces have been changed to plus, and carriage return line feed, the sequence /r/n, has been encoded as 0D0A, which is a hexadecimal encoding of those special characters, and then we follow the same pattern for the rest. So this is what it means to have content type XWW form URL encoded. This kind of encoding is called URL encoding. This part, which is commands equal to, comes from the name of the form, as we will see shortly. When testing, it is very useful to be able to re-edit and send a certain request all over again. And because if there is a small typo somewhere, you don't have to recreate everything. You can just do some sort of local change. What happens if we actually were to edit and resend is something we will take a look at later. For now, we are just going to go ahead to the next step. Let us solve the small puzzle of the tab or extra space that we get when we first see the FairShare app. So here there is an extra tab. Normally, HTML is not supposed to be sensitive to space. For example, here, if instead of having a P there and a div here, I instead have them like this, or if I have an extra space here, I save it and I reload, and then I do our usual thing, which is register somebody and just test it out what happens. Okay, fine. Now go back and let's try and reload this thing to get back to the state that we want. So where is this tab coming from? Unfortunately, it turns out that if you look at this carefully, this text area ends over here and the end tag begins over here, and there is an extra tab over here. So it's somewhat annoying that HTML is suddenly sensitive to these kinds of things in a few odd places, and otherwise it isn't anywhere else. But that's one of those things that we simply have to live with. And extra spaces, especially in templates and so forth, is one of those minor niggling details that can sometimes have surprising consequences. So let's try and remove this space from here completely and then go back and see what happens. Let's reload this, and aha, now our help sentence, which we put here as a placeholder, is actually visible the first time you load it. So you have to be quite sensitive to these kinds of things, especially when it comes to the browser. There are not too many of those, but I'm giving you very simple examples to sensitize you to be careful in looking in detail at what you see when you are doing web programming. The next example that we will have of this, unfortunately, is more severe. To see this example, let us do the following. Here in this form, we have an ID tag. How the form is organized is like this. There is a form tag which ends over here, and inside the form tag there is a label and there is a text area with a command sequence placeholder, some columns, some rows, and so on and so forth. And you have two buttons. You have a button submit and reset, and whose titles are submit form and clear form. And this ID here, fair share input, tells is useful on the server side to find out which button was pressed. So far so good. Now let's make one change over here, and before that, let me just make sure that you understand the nesting of the form, the label, the text area, and the input on the actual display. So on the display, what we have here is, here this end your command sequence terminated by end, this is the label part, and this text area is over here, and then the input buttons are over here. Let's see what they look like first in the browser tools. So this time we will go to the inspector, and the inspector shows you the elements that form this screen like this. When you hover, it tells you which element it is currently looking at. So body occupies the entire screen over here, the part that is highlighted. And if you watch in this area, when I hover over the body, you will even see the dimensions of the body. If I go inside, I have this div which is only slightly smaller than the body, and here I have the primary application. This is the header which it is highlighting. This is the welcome tag. Here we have one paragraph, here we have another paragraph, here we have the form, and here we have yet another paragraph, and the entire thing ends over here. So let's take a look. This is the web version of the fair share application. Then we have this separator, which is not doing anything much. The separator is indicated by those dotted lines. Then you have the form. Here we have the label of the form. Then you have the text area alone. And here we have a small separator. Here we have one button. As you can see, it is highlighting all these elements on the other side. And here we have the other button. Finally, the form ends at this point, and there is a little space over here. Normally, these days, you don't have to create these kinds of things, but this is these kinds of spaces and all. You can take care of it in a more sophisticated form. But for simple applications like this, whatever does the job is typically good enough. Okay, now let's take a look at the problem that sometimes can be created by things like this. And for that, we will go back to our network tab. Let's make a change and see what happens. We know that this form works perfectly fine, but let's do this. Something like the form has many different tags in it. One of these happens to be called name. So instead of ID, let's change this thing to name. And write this thing, go back. Now I'm going to reload. And I will put the commands we want, F1, F2, F1, F3, whatever, expense, F1, 200, end, and let's submit the form. What happened? We submitted the form, but there is no result at all. As we will see for this example later, if you go and look at it on the server side, you can find out what has gone wrong, but there's something interesting you can find out from the client side as well. If we look at what happened here, it turns out that the request headers tell us that the content length is 0, which basically means that all the text that we entered was never sent by the browser. So what is going on? Well, it turns out that there are many different rules plus heuristics that browsers use to decide what to do when something unexpected happens. So here the browser says this is the name of the form, but then how do we know that it is associated with this text area? That's the question it has to solve. It can use heuristics such as the text area is inside, but it also has rules which require that this thing should be ID, and if we put ID back then and reload, we have something simple, F1 end, submit, we get some result, and of course the content length is non-zero. But let's try the same example with a slight change. We will change this back to name, and instead we will remove this form tag over here, go back to our system, reload, then now it still works. What just happened? Well, the answer turns out to be that if the text area's indicator is missing, because the text area is nested, it is considered part of this form. Why are there strange rules like this? Part of it is that when the web began, people began by doing strict rules the way we normally do it in a programming language. But because HTML was written by people without any programmer training, what happened was that if the browser tried to be too strict, it started irritating people, and some browser vendors came up with the idea that you should try to be permissive. Of course, once people try to be permissive, they start putting in heuristics instead of strict rules, and over the years those heuristics have ballooned into all sorts of strange things. So for example, when I first encountered this, when I was building this thing, I actually had no idea what exactly was going wrong, because nobody can keep syntactic details like this just at the top of their mind. So I did what everybody would do. Try to craft a nice query until somebody somewhere has encountered this before and come up with a solution and get something going. Alternatively, try to find the original document which spells out what the rules are supposed to be. And both of those methods, shall we say, of approaching these kinds of problems is what people eventually have to resort to. Here, for example, are the pages that I found. One page said text area value not getting posted with form, And I didn't really notice, for example, this person has both name and ID, and then on this thing he seems to have something form, etc., etc. But then his text area was outside the form, and then I just started looking down below. What are some things that look like they will work? So it has something to do with text area inside the form maybe, or something about a form ID attribute. And somebody else finally said something that worked, that using the form attribute, etc. So I figured it has something to do with form attributes and IDs and so on. And then finally I looked for what the actual specification is, and it seemed to say that the text area form ID should look like this. And I originally had name in there, but then I said, okay, let's try ID and see what happens. And then that is what worked. Of course, before I found that out, I had to go through other things. For example, text area not posted by the browser. And there is some discussion here. But this person has a clear mismatch between user form, the spelling over here, and USR form, which is the spelling over here. But at least it's an indicator that these are the kinds of things that are possibly wrong. Now let's see if we can go and fix that. So I guess this is all good. Then we have our system here, and let's submit the form and see that everything is fine. Okay, looks good. The point of this example is that sometimes there are very subtle things. But the indication of failure at least is reasonably clear, because you can actually check what it is that you are sending from the browser. So browser tools in general will help get you out of many sort of irritatingly tricky situation, but it does require you to pay attention to a lot of details, and as usual do intelligent searching on the web to find out what exactly is going on. Some people find themselves fascinated by the kinds of details that we are talking about, and then if you want to find the definitive answer to many of these types of questions, a large number of explanations boils down to knowing the official specification as given by W3C. So when you search for W3C form specification, you find these kinds of things. And if you look for forms in HTML documents, it will say, for example, things like there is a text area and what are all the attributes. And it says things like this: the text area element creates a multi-line text input control. User agent should use the contents of this element as the initial value and should render this text initially. This is why the tabs and spaces between the beginning and end of the tag are considered the initial value and are faithfully rendered by the browser. So in a sense, the browser isn't wrong, and neither is the W3C. Because should they argue that, for example, text which is just space should be treated differently from text which is supposedly visible, and these kinds of things you don't actually want to do, because what looks like space in one context, for example, if the background of the text area happens to be a colored thing, then space could be visible, although on a white background it is not. So it isn't that the rules are strange, it's that the idea of what looks good to people is complicated enough that specifying it in great detail is very difficult. So that this is another reason why rules like this exist. If you look at that business about the ID and the form name, then you can find these kinds of things which attempt to spell out, for instance, what it means for a form to have other elements associated with it. Unfortunately, unless you are a specialist and responsible for actually building web browsers, it is unlikely that you would find it easy to read these kinds of specifications, given that we are not really used to them, which is why the collective wisdom of the search engine and sites like Stack Overflow turns out to be the usual thing to do. To understand what happens on the server side, instead of using this fairshare2 file, which goes to the fairshare2 CGI that we have written, instead we'll look at a simplified form of this thing. So we'll use a file called fairshare-post, and here, instead of sending it to our usual command, we will send it to a special command called post data, which simply sees what the server sees and prints it out for us. And then we are in a much better shape to play with it and understand what is really going on. So let's see first what happens. So here we have this file fairshare-post, and because we loaded it with shift reload, we also got this favicon thing, which XAMPP has actually arranged to show this icon here. So for example, this is the favicon that gets returned automatically. All right. Now let's see what happens if we write something and submit this form. Okay, so here, instead of our usual application, what we got is a file which is designed to print just the most interesting parts of the entire environment that gets sent to the system. If you want to see the complete environment, by the way, there is a program called show env cgi, which does the same thing that we are doing, except that it prints a much more detailed and a somewhat prettier report that you have seen before. But let's come back to our system here. So what we have is, first of all, a request URI, something about the remote address. What is the script that is executing? So it's postdata.sh. Here you have XAMPP htdocs, remote user, no query string, no remote host, script name, is it HTTPS? No. What is our server software? This is localhost, etc., etc. Content length 20, request method post, and post data as the browser sends it, and post data after it is parsed out into original commands. So let's see first of all how this gets done. So we have post data .sh. What it does is it has this header which is needed by HTTP. In this case, we add user bin to the path because I happen to be on Cygwin, but other than that, on different operating systems, this may or may not be needed. It checks if the request method is post, it checks if there is a content, and if there is, then it reads the content into this variable called post data. Now it does something interesting. This is an awk script, and here I have just created an array of interesting variables that are relevant to HTTP, and you just loop through them and print the result. And now you post the data as the browser sees it. You de-encode it if you want to see what will happen when those commands are parsed out, and so on. So here we are. This is a basic file which will allow us to understand what is happening on the server side. Now we'll start taking a look at the log files and the overall setup of the server. Let us see what we have in our XAMPP distribution. It's ls, and here is a bunch of things, of which the 2-3 noteworthy things are: there is Apache, there is cgi-bin here, and then there is htdocs. The default service comes from htdocs, as you can see over here. For example, if you just say localhost, it goes to htdocs and it will show you this thing where we have fair share post, fair share HTML, and fair share HTML2. Now, the standard structure of Apache and many other servers is, if you go to this directory, there is a conf file. These are very common names. This is a conf file which contains various configuration details, and there is logs which contains an interesting set of logs. So first let's see what those logs are. Here we have a very standard distinction that is made. There is an access log which shows that a request arrived at all. There is an error log which is written to if there is an error of some kind. And then this PID is used to start a limited number of Apache processes. And there are a couple other things that record what happened during installation and what happens for some secure requests and so forth. The usual way to look at this log is to do tail minus f. Let's take a look at access.log. So tail minus f access.log prints a number of last few requests, and let's create a little blank space so as to understand what happens when there are new requests. So we'll go over here, and when you submit this form, as you can see, a new request just arrived over here. It said that this request is from the local host. It arrived at this time. The method was post, and the URL was this one, fair share post, etc., etc. At this point, no matter what else happens, you know that the request has been received by the server. To verify this, let us go back and add that error to our fair share script. What we will do is we will change this to name and form, and now our browser is actually going to error out. Let's reload, and again we see, first of all, there is fair share post and favicon, both of which are visible on the browser. Then this is another test, and we'll submit the form. Okay, notice that because we added the error, our data is missing, content length is 0, but a new request has arrived over here. So this tells us that whatever happened between the browser and the server, and that even on the server side, no content was actually received. So this is the other way we would know that one part of the interaction, which is to send the request to the server, got completed, but when the server looked at what had been sent, it turned out that nothing had been sent. Now the question here, of course, is exactly where the problem happened. But since the rest of the setup all looks good and the content length is officially 0, which means the content must be missing, and it should be missing on the browser side. This is the use of the access log. And if you have other things like remote host, etc. enabled, in the place of these dashes, you can also see which hosts your request came from. When you first set up a web server, you will be quite surprised and pleased to see that you are getting requests from all over the world when people come to see the content that you have posted. Okay, so after this, we will take a look at all the other logs that the system has. To see what the error log does, we have to deliberately create some error messages. And here the rule is that at least for CGI files, anything that the file writes to standard error becomes an error message. So we have put an error message over here, and now we can go and run this thing, and we should see an error message on this side. So here what I'm doing, let me just make this obvious. So I do tail-f error.log. There were some earlier errors there, and now if I do this, here I get a new message with this information. This is an error message, and the error message was generated by this app, which was referred to by this other app, this other URL. This is how we use the error log. So you could, in principle, at least for CGI scripts, use the Apache logs also for error and application specific logging, and then filter it out. But normally we don't rely so much on Apache logs, and for most applications they will generate their own log. So our next step will be to see how a Java program can manage its logs using Java libraries like log4j. What is it called? Log4j. It is not just that system that is explicitly written error messages are not the only reason why an Apache error log may have error messages. Let's create another error situation. So here, instead of giving a proper path to bash, suppose that I have made a mistake and have a typo here, then in that case you can see the same thing. I have already generated this error once, but just to see it again, as you can see, on one side you get this information that there is error 500, which tells you that something went wrong here, and you can see the status at this point. And here we have response information, plus on the server side we have the server error, and the server error looks like this. It says the system cannot find the file specified, couldn't create a child process, and couldn't spawn the child process. So these things depend on the details of the implementation. And now let's restore things to what they were. So we can go here and fix this, remove all this extra stuff, back, and then submit the form again. This time we go back to our application specific error message, and we can go back still further and fix the issue with the form in the first place. So fair share post, and let's fix this to ID, and that should be that. So we have this, submit. Forgot to load this thing. There we go. Now we have everything working, and this is our application error message. Might as well remove that while we are cleaning things up, and let's comment it out. Go back, and this time right there, and no new error message. So we are all set. We have now seen how errors can arise on the browser and the server side. On the browser, the cause was HTML format errors and the fairly subtle interactions between different elements of the tags. And on the server side, because of issues in, say, in the CGI script or any other method of writing server-side code. On the browser, we were able to use browser tools, but you had to pay careful attention to the behavior of headers such as content length, etc., to detect what is happening in the first place. And we had to know where the issue might lie. To repair the error on the browser side, it was pretty difficult because there is no easy method to understand the very many different inconsistencies that can arise in HTML. For historical reasons, finding out these kinds of issues, I guess nobody has ever developed a good HTML compiler which will do these kinds of compile checking or linting, although perhaps there are such things around. Or there should be by now. It might make an interesting project for someone to do. In any case, because of the load of so many years of history and evolution, there are many strange issues, but we have by now enough sources to figure out where the issue might lie. Plus, it is not just the browser. We also have tools on the server side which can help us understand exactly where the problem might lie. The access log tells us that whether the access has happened at all and with what parameters. And then the error log tells us what could have possibly gone wrong. Together with this split between the browser and the server and these tools, we have to put together what happens to the interaction between these systems. As you can see, this is quite different from doing straightforward application debugging using debuggers. Even with GUI programs, such debugging is not simple because the behavior of events and callbacks is difficult. With these distributed systems, things are hard because we have 2-3 different types of systems collaborating with each other, each with tremendous amount of history and reasons why they are the way they are. In our simple setup, both of these systems are on the same machine, easily accessible to us. In a more complex real-life system, there are still other sources of error, sometimes having to do with the DNS, with the intermediate routers, and many of the elements that don't show up in our simple case. But as time goes by, we will take a look at as many of these as is feasible within our limits. To successfully cope, you have to build in your own understanding a careful delineation of the kinds of issues that can arise on browsers and the kinds of issues that can arise on servers. As with all bug fixing and debugging, the overall process is the same. You try to understand each part which is supposed to work and put together part by part a path from where we started to where we are supposed to end, and whether each link within the path is tested. In fact, in our setup, we did not just simply try to understand our application directly. We in fact built a mock system which had the UI of our actual system, but the backend was completely different. So this is another interesting thing that the web permits. Relative to things like GUI, mocking means creating a piece of software that takes the place of another but doesn't always complete all the original software's functionality, is relatively easier in the web because these are independent systems that we can test independently. So as you can see, there is complexity, but there are also saving graces, and the web has a remarkable elegance to it. We can use some of the same tools like shell scripts and all, which are useful in simple things that we do on desktop, and make them usable on the web using tools such as CGI scripts. As we go on with more complex servers, there are new situations arise, but then new tools are also developed to understand exactly what is going on. So all in all, we have to learn these programs together with the tools that are needed to understand them. So this is our summary for this session. For the next session, or let's say the sub part of this overall session, we will look at application side logging using logging libraries, and we will look at some other tools like curl, etc., which can be used for this kind of testing on a more automated basis. Okay, thanks. See you for the next part of this session.